Do I have to repeat the explanation again on this graph? So this diagram tells us that cohort component method still being used in the real world. At least the UN World Population Prospect use this method. So once you go use that kind of data, so you know that which method that they use and what is the assumption for the population projection result from the UN, okay? And this is the recursive process. So you go estimate fertility, mortality, migration, and you run the cohort component method and you compare to the benchmark. And you probably can adjust the benchmark as well. If it's matched, you proceed the next period of projection. And if it's not matched, so you go and re-estimate the fertility, mortality, and migration again. And this is the recursive. You do as many as you want to protect it. It's depend on how many period that you want to protect. Okay. Is there any question before I move? So if no, okay. So we now going through the step of cohort component method. So let's read through this step. If you get confused, it's okay. We just try to get used to the step by step, and we get used to in more and more on the calculation. So for the first step, we need to calculate how many members of each living age cohort will survive the current projection interval. So we have to calculate the number of survivors from the base period to the next period, from the base period to the projection period, okay? Step 2, either add the immigrants to each age cohort and subtract the immigrants, or more simply add net migrants to each age cohort. So if your countries have the substantial or significant migration, international migration, so you need to consider the number of migrants. You can use the net migrants at the end, or you can add the immigrants and subtract the immigrants, okay? Sometimes, many times, many countries have difficult to get the information from immigrants. So they make it like, they make the assumption of close migration. So what does it mean, close migration? Come on.
Seek asylum for in any country for any political reason. Sometimes people, due to war, people forced to migrate another country, like Syrian people migrate to the Germany during the war.
What is the close migration? That's my question. The definition of close.
Close migration.
Yes.
Oh, sorry.
Yeah.
Close migration means there is no migration actually.
Exactly. Yes. So we assume that no migration. Actually, there may be some migration as well, but the net migration is about to cross or reach to 0. So we call it close migration. Many times in Thailand's population projection, we use close migration because, you know, we know that we have illegal documented migrants in Thailand, but it's difficult to estimate number of illegal migrants. So in many data sheet, we can see net migrants. Net migration of Thailand is close to 0.0 something. So we make the assumption for Thailand's population projection is the close migration. But recently, some of organization in Thailand, they consider the substantial of migrants. So they estimate the net migrants, and we just simply add the net migrants into the results after we do the cohort component method by considering only fertility and mortality. And after we finish, we add the net migrants into the results. Okay, it's easy just to add the total of net migrants, but we have to consider the age and sex. So that means actually it's not that simple. So we have to estimate by age and sex of migrants as well. That makes the method more complicated. So if you like to learn the population projection of Thailand done by IPSR, so you will see at the bottom of the table, you can see the net migrant that we just have only the total and add to the total population of that year. That's it. We don't, in that report, we don't add migrants population by age and sex. We just add total population of migrants. Okay, let's get back to the step. Okay, is that okay? Does that make sense? Okay. Step 3, we calculate how many births will occur during the current projection interval and divide them into boys and girls. Okay, we have to calculate the number of births, and because the population projection we do by a separate male and female, so we have to calculate how many female births, how many male births. We're gonna work on that. Step 4, calculate how many of these birds of each sex will remain alive at the end of the projection interval and adjust for net migration into the youngest age group. So after we have male and female births, we have to estimate how many of them survive until the next survive until the end of that period. And if you consider the migration, so you are allowed to add the migration in this step as well. And you have to consider the age and sex of net migrants as well. Okay. The last step, we repeat the calculations of next projection interval. What do we have about the assumption? We have to make the assumption about fertility, mortality, and migration. Okay. During each projection interval. What does it mean? It means that you are allowed to change the assumption for some interval projection. For example, so you plan to do the projection for 50 years ahead in the future. So 50 years, that's quite long time. So you can divide the time period and you make the assumption for each time period. For example, for the first half, you use a certain level of fertility, mortality, and migration. But for the second half interval, you can revise the assumption. For example, you may reduce the fertility because you expect the lower fertility in the next 25 years, right? So you can revise your assumption for each period of projection interval. It's depend on your knowledge. It's depend on your expertise, right? It's not that simple. So if you do the population projection, so you need to include many expertise to discuss about fertility, mortality in the future. It's depends how long are you gonna project. Okay. Next method does not require an assumption for constant rates. So because of the method, you will see the constant rates that you will use. For example, the mortality patterns and fertility patterns. You need the mortality. Let me see. You have death, a specific death rate in life table, and you make the life table, and then you use the it's NLX. It's what's that called? It's the person years lived by population in that age group. You use that column in this population projection, and then you have to have the specific fertility rate as well. Okay, so if you use the constant vital rates, so no need the assumption for that because you already have at least the observed data or the estimate from somewhere else. So, yeah, so you make the assumption for fertility, mortality, and migration. Okay, question. Student who are online, hope you can hear me well, no?
Yes, it's very clear.
Yes, Ajahn, we can hear you.
Okay, next. Okay, this is the diagram. Step 4 cohort component method. It shows the overview of population projection method. What do we have here? We have input data in the blue box. Can you please help me? Thank you. Yeah, I can see everyone. So you have input data in the blue box here on the upper panel here. And you have intermediate indicators in the purple box and output data in the green box. What is the input data? You see, you will use all of your knowledge from the class on this calculation. So we need base population. Base population estimated population by age and sex. Okay. Next, we need fertility hypothesis or fertility data. We need mortality hypothesis, sex ratio at birth, internal migration hypothesis. What is the sex ratio at birth in your own country? Do you have any idea? What is the general or typical sex ratio at birth around the world? Oh, come on. Huh?
105.
105, right? Yeah, it's a
110.
general one. Yeah, it can be lower or higher than this. It depends on your context. For example, in China, what about the sex ratio at birth in China? Higher or lower? Higher, right? Yeah, so you learn from the class, so I don't have to go back and talk about it. Next, so I did talk about the international migration already. So let's move down a little bit. For fertility, you need to consider the level of fertility. We usually consider the TFR. For the TFR, it's contributed from age fertility, age specific fertility rate, right? So we consider this one, age specific fertility rate. For mortality, we consider life expectancy. From life expectancy, we have to think about the life table. In the life table, you have the probability of dying, right? So, but here we need the probability of surviving. Okay, it's just the opposite side, right? So this is the probability of surviving. And next, sex ratio at birth. Now you have your own idea for your own countries. What is the sex ratio at birth in your own countries? But in general, for example, in Thailand, we use 105. So 105 boys over 100 girls, okay? And next, net migrants by 6 and age. Just in case that you cannot ignore the migration in your country, so you have to consider the net migrants by 6 and age. Are we good here? Still okay, no? Next panel, we consider the intermediate indicators. So we need to consider the population from age 5 and over, and also from population from age 0 to 4. We consider these two set of population differently. So we will see in the next diagrams why we have to consider it differently. Yeah, as you can tell from the arrows, to estimate the birth, so you consider just not only the fertility here, right? Fertility. But we have to consider the survival as well, because not all birds survive until the end of the time interval, right? So, yeah. And next output, you will receive projected population by age and sex with close migration or with open to migration. Okay, I'll stop here. Is there any question? Hope you can follow me, no? Okay, are you okay with that?
Ajahn, can your mic be set a little louder? Because we have to try hard to listen. Can your mic set a little louder? Yes.
Louder, okay. Yeah. Thank you. So,
Your voice is a little bit far.
oh, I see. Yeah. Okay, is it okay for you? Not yet. Hello? Better? Hello? Hello? So I have to disclose. Sorry. Do you need me to explain somewhere again because of my voice? It's not that clear. Do you need me to explain it again? Okay, if no, I move on. I need to share these slides on my iPad. I stop here. Mm. Okay. I don't know how to get rid of my face on this screen. Uh-oh. Okay. Mm. Yes, anyway. Cool. So did you have time? Oh, thank you too. Thank you. No, I've done it. Did you have time to consider this diagram? How do you feel? Is this help you to understand? Oh, you are so quiet today. Are you okay? Are you happy?
I understand some, but I'm confused in some parts.
Yeah. So which part that you can understand and which part that it seems to be difficult for you? So, right? So which part that makes sense to you? At least my diagram makes sense to you.
Sometimes I'm confused in formula like what is T, something like that.
Yeah. So N. So let's go to the formula first, no? At least you know the definition of each symbol, and then it makes sense to you. So for example, what is the N? Do I provide a definition for you? Yeah, here, right? Okay. So N is the number of population. And this is referred to female only. Right? Refer to female only. And X is the specific age. And what is 5 here? Interval, the time interval. What is a T? At time T, right? Here is time T. And here is time plus 5. That's mean in the next period. At the end of the period, right? What is L? Actually, it's 5LX. What does it mean? It's from life table. What does it mean?
Number of people that survive from the period.
Almost. It's a person year. So number of population and the person year lived by the population is different. Do you have this idea, right? Okay. So the person year is not the number of people. How many people in this class? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 3 more. It's 12. There is 12 population in this class. I ask you, what if these 12 people, do I count myself? Not yet, right? I forgot myself. Okay, it's 12. So let's say 12 population. What if these 12 population live from the 1st of January until the 31st of December? What is, how many person year live by this 12 population? Yeah, from the 1st January 2022 to the 31st of December in 2022, I asked you how many person year live by. I didn't share, right? All right, thank you. Should I move to use that microphone just in case? Okay, let's get back. 12, exactly. Yes, correct. Easy, right? Now I ask you, in the case that all of you, 12 population, live until the 31st of December in 2023, how many person year?
24.
Exactly. Now you know the difference between the number of people and the person years, okay? Okay, now we get back. Okay, what about this one? See. See, also is a person year, but is the cumulative person year from any of age until the end of a life table, right? So you have to sum up, right? So did you practice the life table on your own, right? Okay, good. Now you are more familiar with this formula. So I need you to consider the diagram first, and then we come back to the formula later. Recording in progress. Okay. I would like you to consider only the yellow, the yellow part in this diagram. What do we have here? Age, right? This is from 0 to 4, 5 to 9, 10 to 14, and so on. Is that okay? Okay. So I ask you, how can you know? How can you know, or how can you calculate the number of population that live, that can survive to reach age 10? Who are they? So it's just the population from the previous age group, right? So now we consider to do the population projection for 5-year interval. For 5-year interval. So for like 12 people will live until the next 5 years. This is 2022. In the next 5 years is 2027. Okay. So if we consider in the year 2027, how can we know that who are the survivors in the 2027? So we come back in the year 2022 and see how many people live and can survive until the next 5 years in 2027, right? This is the same idea. So let's get back and consider. So the population change with the population change for this yellow part. It's just only death that contribute to the change. If we don't consider the migration, if we have the assumption of close migration, it's just only mortality or death that change the number of population. Is that correct? Okay, I have to refer. What is the component of population? Yeah, there are only 3 things: fertility, mortality, and
Mortality and
migration.
migration.
Exactly. Thank you, Lemon. Yeah. So if we have an assumption of close migration, now we have only fertility and mortality. But for the population among this yellow set, how can anyone get birth and just jump into age 10? No. That's why we dismiss the mortality and dismiss the fertility, and we have only mortality or death for this population. Okay, so how can we know that the population at age 5 to 9 will survive until age 10? Yes, we consider only mortality. And to know who survives, we need survival ratio. To do the calculation, okay, how many people who supposed to be survive in the next 5 years or in the next age group, okay? So people who age 5 to 9 will survive until age 10 to 14. Some of them might die before reach age 10. Again, from population from age 10 will survive to age 15 to 19. For sure, some of them might die before reach in the next 5 years, right? So this idea is the same for every age group within this yellow panel, yellow table. Okay. Now we come back, we consider the year interval, the period of projection interval for 5 years. Because of what? Because of life table that we have here is 5-year interval. So you can do the same. I mean, you can only consider the same interval. You cannot do like 6 in the next 6 years. You cannot do that. You can do only 5-year interval because in your life table have this kind of information. You will know in the next 5 years from age 20 to 25, this is the 5-year interval. You can use the survival ratio to calculate how many live until the next 5 years, okay? Is there any question? Does that make sense?
Then one thing we may consider to note is Normally in live table, the age group, there are two age group, 0 to 1, 1 to 4. So in this cohort component method, we have to combine these two age group into one, 0 to 4. So we may note that. So
Yeah.
in live table, we may combine the probability of dying or probability of surviving into these two age group into
Yeah.
new age group 0 to 4.
Yeah, thank you, Kim. Yes, in the life table, you have 0 to 1 and 1 to 4, right? So you have to combine. If you would like to do the 5-year interval for all of age group, you have to combine. But if you like to do the single year of age, you can do that as well. But the time of interval supposed to be only 1 year. So it's depend on your life table. If you combine and use it as a single year, so you can do the cohort component method by using single year as well. But here, single year, that's too much to work. You can see on the UN population prospect, they provide you single year and the 5-year, but usually we use a 5-year interval because, within 5 years, you can see some change. But every single year, it's difficult and it takes a lot of time to work on that. Even you just download and use those data, you don't do the analysis for every year. We usually do like every 5 years, 10 years. Okay. But thank you for raising this issue. Now we get back to our diagrams. Now we are talking about 5-year intervals. Okay. Okay. Now we get the sense of how we calculate the number of survivor. So let's move to the formula. How are you people who are online? Are you okay with me?
Yes.
Actually, I don't understand most of the parts, but I try my best to understand and calculation. The theories are very challenging to understand for me. Again, yes.
But you understand the idea how we can calculate the survival for this population among the yellow table.
I actually I understand the yellow part, but I cannot relate the previous part with this slide. That's why.
Okay,
Yes.
I can do it one more time and then we move to the formula. The formula probably help you better understanding. Okay, I do this one more time. So let's think about the population at age 5 to 9. So think about the population among children aged 5 to 9. What is the age in the next 5 years for 5 to 9?
10 to 14.
Exactly. They become age 10 to 14, right? But not everyone survive until the next 5 years, right?
Sure, Ajahn. Yes.
Yeah. And what is the age of children age 10 to 14? Among age 10 to 14, what is the age in the next 5 years?
15
Yes.
to 20.
15 to 19.
Yes. They become age 15 to 19. But some of them may die, right? Again, so in the next 5 years. So let's see, this is 2022 and the next 5 year is 2025. Okay. For those who are 20 to 24 in year 2020, what is the age in the next 5 year or in 2025? They become age 25 to 29, right? Yeah, and so on. Okay. Is that okay with you too?
Yes, yes,
Okay.
Ajahn.
Okay, so this makes sense then. Now we move to the survival ratio here. We move to the formula. To get the number of population, sorry, we consider female dominant first. Okay. We talk about female in the next 5 years. How many women in the next 5 years in each age group? So this is the number of female at age x to x plus 5 at time t plus 5 or in the next 5 years. To get this number, we need to consider the number of female at age 6 minus 5 or previous age plus 5 years at time t. Okay, so this is the base population. Okay, so we consider the base. Yeah, we consider the base population. Again, I do it again. Number of female at age x minus 5 plus 5 at time t and times this is the survival ratio. How can we calculate the survival ratio? We use the person years of female at age x to x plus 5 over person year of female at age x minus 5 or previous age plus 5. Does that make sense? So to get the survival ratio, we take the person year of female at age x and over the previous age. Okay, right? So we get the person year. Sorry, we get the survival ratio here. So from this number of female at age x minus 5 to x plus 5 at time t times survival ratio, and then we get the number of female at age x to x plus 5 at time t plus 5 in the next 5 years. Does that make sense? Make sense?
Yes, Ajahn. But I have one question. Why do we take female population only?
Yeah, that's good question. Because we are going to do the female population projection first, and then we do male separately.
Yes, Ajahn. Thank you,
Yeah.
Ajahn.
Yeah. Can I stop here? Are you with me? I can explain more and more as many times as you need. Just request. Okay. Okay. I guess we good with the yellow part. Okay. Single. This is the most, the most part that we have to work on population projection. Now we move.
Ajahn,
Yes.
sorry. To give the formula for the 85 years and above in the gray color, but how can we calculate the numbers of female and zero age group? How can we calculate this one?
That's good question. We are going to work in the next slides. Remember,
Yes, Ajahn.
yeah. Before we are going to do that, we do the simple one first. Sorry. Okay. I start from the simple and getting more difficult and difficult. Okay. Next, for the green part, we are going to calculate the number of population for the last age group. Let's say in this case, the last age group is 85. It can be any age group that you are going to project. It's dependent on your own data. It can be 75, it can be 100. But in this case, in this example, I take 85. If you do for age 100 and plus, you can adapt this formula for the last age group. Okay. So to calculate the number of population at age 85 plus or the last age group. So you take the number of female at age 80 to 85. That's mean here. Okay. And we add the number of female at age 85 until they die at time t. We'll submit as time t. Okay. Okay. We will add this two set of data of these two age group and times the ratio of survival. But here we take the cumulative person year of female at age 85 over the cumulative person year of female at age 80. From this formula, we will get the ratio who can survive from age 80 to 84 up to age 85 and plus. So you take these people and time the ratio of survival at the end of age group. And then you get the number of female at age 85 until they die at time t plus 5. Okay, does that make sense?
Yes, Ajahn. I have one more question. For those countries who have the higher numbers of adult people, for example, Japan, it has the elder people. That is, I mean, Japan has the more population on the age 85, 90, 95, 100, something like that. In this case, do we need to use the same formula as numbers of 85 plus, or do we need to separate the age group separately?
Yeah, it depends on your life table. For Japan, they have very good data and they can have life table up to 100 plus.
Yes, Ajahn, yes.
Yeah, so you can adapt this formula to be. So you change 85 to be 100 plus. So this should be 85, 95. This should be 90, right? So you can change. Does that make sense?
Yes, Ajahn. If so, if I want to calculate the numbers of female at 80 years in Japan, do I need to use the above formula, right?
Yeah, you need to adjust the formula. So it can be 80, right? You need to know 80. You need to calculate for 80, right? So you stop at age 80 and then you do it this one. So the last age group supposed to be 80, right? 85 change to be 80, 85 change to be 80, and 80 change to be 75.
Actually, Ajahn, I want to know the life table of Japan has 100 years, 100 years.
Yeah, you have to find it. You have to find it. I'm sure that they do.
Yes. If I want to calculate the numbers of female at 80 years in Japan, I need to use the above formula.
You mean the yellow formula? Yes.
Yes, yes, yes. I need this one.
Yeah, the green formula is just for the last age group. The yellow you can apply until the age right before the end of the table. You know what I mean? Oh, it doesn't make sense. Okay, for this formula, the green one, you apply for only the end of your last life table or your last age group that you would like to protect it.
Yes, yes. Thank you, Ajahn. I got it.
Yeah, okay.
Yes, thank you.
Okay. Is there any question before we move? So we finished two parts. The yellow part from age 5 to 80. Okay, actually, I supposed to put, yeah. And the green one is just for the last age group. Okay. So now we move to number of birth. How can we calculate number of birth? What time is it? Okay. So this is the formula. All births, birth to female. This is the number of birth to female age, x to x plus 5 between time t and t plus 5. Okay. You see, if you use x to x plus 5 or 5-year interval, so the projection period, the projection interval supposed to be the same from time t to t plus 5, 5-year interval. Okay. So this formula, this is the number of birth. So you know the number of births is the birth to women only, not to men, right? Because, yeah. This is the number of birth from age x to x plus 5 between time t and t plus 5. Okay. If we do the projection from 2022, so we are going to calculate the number of birth between 2022 to 2027. And this is the number of birth. Okay. So let's take a look on this part first. This is the N. N means the number of population, number of female at age x to x plus 5 at time t. And we add the number of female at age x to x plus 5 at time t plus 5 and divided by 2. Here, we are making the average number of women who contribute the birth between time t and t plus 5. So let's see. What is the reproductive age?
15 to 49.
Good. 15 to 49. So let's see if we don't consider the teenage pregnancy. So we start from 2020, from age 20. So we are going to consider the number of birth between 5 years. Let's consider from the woman age 20 to 25. You know, this woman age 20 to 24 and age 25 to 29. You know, some of women whose age 20 to 24, they get pregnant within 5 years. If their age 24, so let's say, sorry, change it. If their age 23 and they get pregnant, they are going to give birth when they about age 24. But we consider the time interval within 5 years. That means when they get pregnant and give birth, they get pregnant at age 23. What is her age in the next 5 years? 28.
28.
Yeah. So in the next 5 years, she become age 28. When she get pregnant, she age 23. So, you know, she is moving between these two age groups. Some of them may give birth and still stay in the same age group, but some of them may move to the next age group within 5 years. That's why we take this women at age t, age x at time t, and age x plus 5, at age x at time t plus 5 all together, and then we make the average by divided by 2. Okay, so we get the average number of women who give birth between 5 years. Okay, and then we times, what is this? Fertility. A specific fertility. Fertility from age x to x plus 5. and we times 5. Why we have to times 5?
They may have multiple births in these 5 years. That's why.
Yeah, the interval is 5 years, but age specific fertility rate is just for 1 year. That's why we times 5. Okay, does that make sense?
Ajahn, I have a question.
Please.
As the reproductive age is 15 to 49, then why you choose 20 to 24 for the first group? Why you exclude the age group 15? Because as we know, the X in currently 2022. So in 2022, there are age group 15 also exists.
I don't exclude them. We will include from age 15 to 49. This is just an example. Okay, so I start from age 20. So I don't exclude them all. So we will see in the calculation, we include all of them.
Okay.
Are we okay with this formula?
Yes.
Okay. What about people in class? Are you okay? Okay, now we get the number of birth within 5 years. But we're not done yet. So this is just a formula to calculate total birth. It's just another format to write in total. Okay, so we make the sum of birth of the number of births between age x to x plus 5 between time t and t plus 5. And this is the formula. So we get the number of births between time t and t plus 5. Okay. This is the total birth, which includes boys and girls within 5 years. So we have to, now we are working on the female dominance. So we have to find only number of female birth within 5 years. We take this formula. Number of total birth, right? Yeah, you see. This is a total birth. And then we times the ratio, the sex ratio. So here's the sex ratio at birth is 1.05. What does it mean? We have 105 boys over, what is the total births? 100 girls plus 105 boys, right? This is the ratio of male over female, male over total births. But we need female births only. So we make it 100 female, over 100 female births plus 105 boys. Right, so we make the formula simple by divided by 100 for every item. So we get, you see, this is become 1, this is become 105, and this is become 1. Okay, now we get number of female over total birth. This is the sex ratio. Male over total birth. Is that okay? So from this ratio, we take total birth times the ratio of female birth over total birth. What do we get? Good. Okay, go back. This is total birth, okay? And we times the sex ratio at birth of female only. So we are going to calculate. What do we get here? Female birth between time t and t plus 5. Yes. Okay. First, we get total birth from fertility as specific fertility. We get total birth and then we find female birth. We're not done yet. Not all female birth live during these 5 years. Okay, some of them die. Okay, that's why we take female births times survival ratio. And then we get the number of population. The number of female population is 0 to 5. How can we calculate the survival ratio for those who age 0 to 5? So we take person year of female as 0 to 5 over radix times 5. Why we have to times 5? Again, because of the time interval is 5 years, and the radix that you do in life table is just for only 1 year, right? So that's why we times 5. Okay, now we get the number of female age 0 to 5 between time t and t plus 5. No, it's called at time t plus 5 because we calculate the total, we calculate the birth between time t and t plus 5, but at the end, after we calculate the survival ratio, we get the number of population between age 0 to 5. Okay, I stop here. Question before we take a break. Please.
Again, as we calculate the female here, do we need to calculate the male with the same formulas other than the total birth? Because in case of male, they can give birth. This I understand. But in case the previous one, we need to calculate for the male as well.
Yes, we have to calculate for male birth as well. Yeah, but it's simple. It's easier, I would say.
Okay. And why this cohort component is called the female dominant?
So why what?
Why this is called the female dominant projection actually?
We are going to do male and female population projection separately.
No, Ajahn, I said because as you mentioned, the steps for the cohort component female dominant. Why this is called female dominant projection?
Why is it for female dominant?
Yes.
How can I?
All are females here, that's why.
Because we are going to do female population projection separately for male. So we need a set of formula for female only. And for male, we do another calculation in the next slides.
Okay. Okay,
Yeah.
Ajahn.
Yeah.
Got it.
So in case that you have question before the break, yeah, please ask.
Ajahn.
Yeah, please.
Yes, yes. I have one more question. In live table, as already Ken mentioned, in live table we have zero each group as and we have 1 to 4 each group. In this types of live table, how can we calculate the numbers of 1 to 4 GS people? Is there any specific formula for this each group in calculating the projection?
So you ask in live table, how can you calculate the number population in live
No,
table?
no, Ajahn, no. In live table, the age groups are the first one is zero age group, and the second one is 1 to 4 GS. It has two separate age group. In this case, how can we calculate the numbers of the projected population and 1 to 4 years age group?
Yeah.
Is there specific formula, or
Mm, mm.
do we use the same formula as usual?
Yeah. In live table, you do 0 to 1 and 1 to 4 separately. But here for population projection, we do combine those age group. Okay, for
Yes,
population
yes.
projection to make it easier. But in the case that you like to project for single year of age, like 0 to 1, 1 to 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. If you like to do that separately, the year interval of population projection is supposed to be a single year as well. Okay, so you just adapt this formula by changing number of year intervals, which is supposed to be 5, you change to be 1. If
Yes,
you like to do, yeah, single year of age. But I like to show you 5-year age group because usually we use the number of population every 5 years because every year is too much and we don't see the difference or the change between the single year interval. But we do 5 year, as you can see from the UN population prospect. Once you download and you usually get trouble with having like every 5 year. Sometimes you like to have the year between that 5 year. You cannot do that. You cannot have it because they do it for you just only every 5 year. But in the case that you like to have every single year, you can do that as well by have the year interval for 1. You make it 1 rather than 5. Yeah.
yes, Ajahn. Thank you, Ajahn.
Yeah. All right, I stop here. So I give you some time to think about it. And in the case that you need me to explain more, so you can come back and ask me again. I can do as many as you want. Okay, we stop. Now it's about 10:30. We come back at 10:35, 10:40. Okay, we come back at 10:40. We can come back at 10:40. You take a break. So we're waiting for a few people to come into the class. How are you, online people?
Yes, Ajahn, we are here. I'm here. Sorry, now
Okay,
we are. Yes.
I'm here too, Ajahn.
okay. Still feeling okay?
Sorry.
After doing so many formulas, we will have a few more to come. So, Mel, yeah. I think everyone is ready in the class. So before we move, is there any question or do you need me to explain in some part for better understanding?
I think it's
ค่ะ
I'm understand, but I think if we try to calculate by ourselves together in the next, I think it will be better. And now sometimes that still confused and sometimes they understand. But if we try to calculate in the next, I think it's very nice.
Yeah. I would like you to get the idea how can we not calculate, how can we get the result of each part? That's the idea. For the formula, you don't have to memorize everything. You just understand
Yes,
how this part come from, but you don't memorize it. Just
yes.
yeah.
I think it's in each part is the result from each part is understand, but when I see in the formula, maybe sometimes have a lot of the symbolic, but but now it's okay because you try to make the understand one by one is very nice.
Okay, I go back a little bit for the yellow part. So we consider from age 5 up to for this example, from age 5 up to age 80, but not the last age group. Okay, for this part, we consider only mortality. That's why we use the survival ratio to calculate with the number of population at time t. Once we times survival ratio, so we get the number of population at time t plus 5 or at the project interval. Okay, for the second part is for the last age group, so you can adapt this formula to the last age group. So this is very special because there are two parts that you have, two age group that you need to consider. The very last one and the previous let's say the age group before the last age group. So you have to consider these two age group and time the survival ratio, which is have different formula, but the same idea. So you need to take account of survival ratio and then you times the number of population, then you get the population at the time of population projection. And the next part is a little bit complicated, how to calculate the number of birth. So to calculate the number of births, you need to consider the age specific fertility, and you take these fertility patterns to calculate with the number of female because of only female can give birth. So Then once we receive the total birth, then we have to consider how many female births, how many male births by using the sex ratio. Okay. After that, we're not done yet. So not every female birds gonna live until reach the next age group. That's why we have to consider the survival ratio as well. And for the survival ratio for the first age group, we need to consider the person year of the first age group and divided by the radix times 5, because the radix is like it's referred to the total births in the life table. Okay. So we finish the total table for female. Now we are moving for male. It's much easier, I think. Okay. So we take the same idea that we do the calculation for the yellow part from female to male. We use the same formula. And we also use the same formula for the last age group as well. The difference is the number of birth, right? You remember this formula. So we take total births and times the sex ratio. Previously, we calculate for female sex ratio at birth for female. We take number of female over number of female plus number of male, right? But here we do different. For sex ratio at birth for male, we take male over the total birth. Okay, that's why we have the formula here. You see, 1.05 divided by 1 plus 1.05. Okay. We use this ratio times the total births between time t and t plus 5. And then we get the total of male birth between time t and t plus 5. Again, not everyone survived during these 5 years. So we take male births between these 5 years and times survival ratio. Again, we use person year from age 0 to 5 of male only, divided by radix times 5 of 5 years interval. And then we get the number of male age 0 to 5. Actually 0 plus 5, which is referred to 4.99999, not 5 yet. Okay. At time t plus 5. Okay, does that make sense? Again, the formula for the yellow part is the same. The green part is the same. Now we're done with the formula. Is there any question? So we move to the very important part of survival ratio. This is the sign. Survival ratio from hx to x plus interval or plus 5. I hope you remember how to find the number of population the number of population at time t plus n or t plus 5. That's mean that the total population, the number of population of age x plus 5 as well. You see the time interval is the same. Okay, so we take the population at age x and times survival ratio. Okay, this is simple. And how we get the survival ratio? So let's move to the formula. To get the survival ratio for the general population or in the yellow table. So we take the person year of age x. It can be at age x plus n, plus n again. But in our previous slide, we take like x minus 5 and 5, right? So it's just another way to write the formula, but it's the same idea. And over the person year of age x and x plus n, okay? Next, for the first age group, we already passed this. We take person year of the first age group from 0 to n, 0 plus n, and we use the radic to calculate by time the number of years interval or time 5. And this is for the formula that we calculate for the large age group. It's the same, okay? This is the survival ratio for different age group that we use for the common population for the first year of age and the last year of age. That's it. Yeah. We talk about this in the diagram already. This is for you. Just I make the definition for you just in case that you need to understand each symbol. Okay, we done for the formula. Are you ready to move for the exercise?
Yes.
Okay. I stopped sharing. I have to stop sharing. Hopefully you will receive this file. Yeah, this is the new file, and it's look pretty much the same as download earlier, but here I just copy some part that it's help you to just copy it easier. What do we have here? Can anyone help me explain what we have in this table?
The number of female.
Number of female
Yes.
population.
And from
As in
0 to
May I ask Abdul first, and then I will let you speak out. Sorry. Yeah. Okay, one by one. Abdul, please.
the first is the number of females between 80 to 85 parts, and is the 5 interval 8.
Mm. Yeah, we got the number of population of female here, right? Yeah. Who else? Two. Can you help me explain more?
Yes, Ajahn, same with Adu.
Yeah, this is the example of population from Sweden in 1993. For this part, we have number of female. And what do we have? What else do we have? What about this one?
Live birth, female live birth.
It's the person years, right?
Person year life, sorry, person.
Yeah, person year of female. How can I find this? How can you find this? If I ask you to do the Sweden population projection, how can you find this 5LX?
We find from the number of overall.
Is it possible to find live table from Sweden? Right, yeah. You have to find from the live table. What if you don't have live table for the countries that you are going to project? In the case that you are a demographer and you asked to work for I'm thinking about the countries that you never heard. For Madagascar.
Maybe use the, can we use the from the UN live table?
So we can just speak that louder.
Can we use the some live table from UN or the some country that have the situation is like Madagascar?
Yes, exactly. You can use those live table. But luckily we do have, we call it model live table. We do have model live table from provided by UN, provided by Co and Gemini. So we have different sources. So you can consider these live tables from UN, from model live table. And what if you have to find those model live table that fit to your data? What do you have to consider? You know, model live table, there are so many live table. How are you going to pick one that fit to your population?
Is considering the mortality, infant mortality, and fertility in the pattern of that.
Yeah, exactly. Yes. You have to consider the mortality and fertility. Yes. Let's think about life table. Do you have fertility in your life table? Do you have any kind of data
No,
of fertility in your life table?
no.
Do you have it? What do you have in your life table? What is the input?
Mortality.
Age specific death rate.
It's the mortality rate, right? Yeah, right. Only input that you have in life table is mortality patterns, right? So you have to consider mortality patterns. And what is the indicator or the mortality patterns or measurement that you have to consider to pick the right life table.
X specific death rate.
Sorry,
ASFR. A specific death rate.
a specific death rate. Yes, that's mortality pattern. What else? Is the right answer. But you know, to consider the whole column of mortality pattern. So what are you going to see? You have the column of mortality patterns. Mortality is specific mortality rate. You have the whole column, right, for the all of age group. And you compare this column into the pattern in your country's data. How can you consider it? Is there any other options that help you to consider? So, you know, you compare two columns. How many age group that you have in life table? 17 or 18 age group, right? And you see, okay, 0.001, 0.002. And then you have this kind of information. How can you compare? Okay, this one fit to our countries. How can you do that?
And try to make a graph like graph first.
Okay, so I'm asking you, so if you don't have life table for your countries, you have to find a life table that fit to the data for Madagascar. And Abdul mentioned model life table. Okay, there are so many model life table around the world for Western country, for East country, for South, for North countries. I ask you, how can you find the right life table that fit to your data? And Abdul mentioned, okay, yes, we consider a specific mortality rate. And you think about the column of a specific mortality rate. There are so many rows in that columns, right? I ask you, how can you know that mortality patterns that fit to your data? Okay, you consider the mortality patterns. You have two columns compare. And how can you know that fit to your data? Is it a little bit difficult, right? To compare the columns. Yeah, that's why I asked you, is there any other options? Life expectancy, right? You just compare only one number, and then you can figure out whether that model life table fit to your data or not. So if Madagascar life expectancy is around, like, I guess, 80. Oh, no, not 80. They have a famine problem right now. So let's say 70 for male and 72 for female, let's say. So you compare these life expectancy to the model life table, okay? You can find, oh, yeah, now we figure out to consider the life expectancy. But there are still so many life table, model life table that have similar life expectancy. Now you have to come back and consider mortality patterns. Okay, life expectancy help you to scope down which model life table that fit to your data. And now you come back to consider mortality patterns. Usually we consider infant mortality rate, under 5 mortality rate, right? Yeah. Now you scope down and then you consider the early mortality, let's see, early childhood mortality patterns. And these help you to consider which live table that fit to your data. Does that make sense? Does that make sense, Abdul?
It's very make sense because
Yeah.
we focus only the at the first group of egg, right?
Mm. Yeah, actually, you can consider the whole group,
Mm.
the whole age group, but usually it's help you easier to make it narrower to consider the information. Yeah. Right. Yes. Okay. Now come back to the Excel file. You have number of female per person years. Sorry, I got lost. Person years lived by female population by age group. And you also have male, actually, down there you have number of male population and person year for male population as well. This is what you have as the base data. What is the base year? 1993. So you have a 5-year interval. What is the projection year? What is the projected year? 1998. Yeah, we plus 5. And as you can tell here, 1998, 2003, 2008, sorry, 2013 and 2018 for both female and male. Okay, this is the input of our projection. Oh, sorry, I like to come back again for consideration of the life table. Abdul also mentioned fertility. Yes, we also have to consider fertility as well. Yeah, you have to find the patterns of fertility. Yeah, again, you consider the TFR first. It's helped you to compare, right? TFR first, and then you find the fertility patterns from a specific fertility rate. Here again, now you are able to consider both mortality and fertility. Okay. For this exercise, I have an assumption of close migration. So for here, for now, so we don't consider the migration at all. We have cross migration. Okay, what should we do? How should we start? We have from age 0 to 4, 5 to 9, 10 to 14, up to age 85. What should we start? So we need to prepare our data a little bit. We have to do the cumulative TX. Can you do that? You remember the formula, right? Please do it. Oh, sorry. You know, I always make mistake doing calculation in front of the class. If you do wrong, please raise your hand and help me correct it. Okay, don't worry. I use this example because I take it from a book and I see the results. I see the input and the results. So I do the calculation on my own and then I compare the results with the book. And then I'm sure that if I do the calculation right, I will get exactly the same results as shown in the books. I also have the complete result here to compare. So we do the exercise here and then I have the result to compare. You can practice on your own. If you get the result, then you do on your own to make sure that you get the same result with the source. And then with TX. Yeah, we do from the end of each group. Are you okay, Liman, too, and Abdul?
Ajahn, can you please just repeat this one again?
Yeah. We are doing TX. From TX is the cumulative. So we start from the end. For the last age group, we just type equal and then take the cell of LX. Right? And then for the next age group, we sum with the previous age group and the current age group. This is a formula. After you done this, and then you can copy to the rest. If you need help, please raise your hand,
23.
or you can let me know online.
Where is the T20?
Yes. And
Ajahn, hello.
Yes.
Where is the D20? Okay, from the last one.
Sorry, this one.
Okay. Alright.
Would you like to share your screen?
Yeah, Ajahn, you're asking me?
Okay, stop, and then you can share.
Yeah, I got it. I got it. I think I'm on the track.
Yeah, okay, cool.
Thank you.
Yeah. So you have to make sure that you receive exact number that I received. Otherwise, it's gonna
Yes,
be
it's
changed.
the same.
Yeah. We do correctness and then we do solvable ratio. So we do for age 5 first. What is the solvable ratio formula for this age group? Remember? Take life, sorry, person year. sorry, we take person year from age 5 over age 0. Is that correct? Remember? Do you remember? Hopefully you can map what we are doing in Excel file to what we discussed earlier. If you can map it, that means you understand. If you cannot map, so that's might be a problem. We have to figure out to map it together. Okay. Okay, so we finished for age 5. So we can copy the data up to age 80. Next, let's go check the formula for the last age group. It's T 85 plus, right? The last age group divided by the previous age group. So are we good? Are you with me, Limon?
Yes, Ajahn, I'm with you.
Okay, good. How are you too? Are you okay?
Yes, Ajahn. Okay, I'm okay, Ajahn.
Okay. What about the first age group? What is the first age group? So we take the person year, age 0 to 5 divided by, the radix, right? Here the radix is 100,000, right? You use it. Yeah, that's it. Now, first step, we are preparing the survival ratio for 3 different type of age group. Now we're ready. Okay. Okay, so now I move to do the calculation for number of female for each age group. So I start with the yellow table first. What do we have? So we know that for those people who are going to survive at age 5 to 9 in 1998, they are from age 0 to 4 in 1993. Is that correct?
Yes.
Yes, we take the number population at previous age and time survival ratio, which is this one, right? Let me see. No, this one. Yeah. So we take the number of population in previous age group who can survive until the next age group, which is LX is at age 5. Okay. Okay, we copy this formula for the yellow part. It's the same formula. Okay, I think you're good. What about the last age group? So we take number of population at age 80 plus 85 and times survival ratio. Oops. Right. You okay? Now we move to the most complicated one. We are going to estimate the number of births, especially for female, between 1993 to 1998. And we have this information, a specific fertility rate from age 15 to age 49. How can we calculate the number of births here? So we need to consider the number of females who can give birth, right? This is 15, so I would like to find the number of female of this age group first. And we need the average by divided by 2, right? And we need to take the whole of this and times, I take the whole of this chunk by put the bracket. And we have to times the fertility rate of this age group. Sorry, I have to put the formula. Oh, it's gone. Right. And not enough. I enter first. Not yet. So we have to times 5, right? I think I do wrong.
Then,
Yeah, I think I do
in
wrong.
that formula, we had combined.
Oh, yes, the next, yeah. Yeah. Thank you. I always, even I did it yesterday, I practiced yesterday, I forgot it. Yeah, the same age group, but the next 5 years. Sorry. Right, this is supposed to be the number, okay. So we take the number of female at the same age group, but with different time, right? Thank you. Do you receive the same number? 150.
Yes,
Okay.
Ajahn, we got the same number, but can you please repeat how we get this number?
Yeah, how do you get this number? Okay. I remove the formula and then you see. So first of all, we have to take the number of female at the same age group at time t and t plus 5. And we make the average by divided by 2. I enter first to make sure that my formula is still, yeah. And we have to times 5 and the specific fertility rate at the same age group, right? And yeah, enter. Okay. Yeah. Yeah.
Just multiply by 5 into a specific fertility rate into population, number of population of 15 into
Mhm.
20 into divided by 2. My result is the same.
Yeah, Kim is helping.
Same age group in the next.
Same age group or different to
Yeah.
criteria and
Yes, exactly. Yes. Hey, hope you received the same result. And now we receive the number of birth from the mother of each age group of mother. What is the total number? Total number of birth. So we sum up this number of birth, right? So we receive the total birth between 1993 to 1998. Okay, so just sum up, and then we have to find the number of female birth by taking the total number of births, and we are going to find the female. We take 1 over 1 plus 1.05, right? Then I put the bracket again. I forgot 2 terms. Yeah. Right.
Then can I show it again? I just made because I was summing up.
Summing up.
Yeah. I got the summary.
Yeah.
I got the summation. Okay. Yeah, then the next one. Yeah, I got it.
The next one.
Oh, okay. What is the formula actually? Oh no. Yes. Yeah, then thank you.
You're welcome. So if I were a student this time, I would be very happy because you can work at home, you can study anywhere, anytime online. So yeah, I'm just envy you. Right. Okay. Next step. How can we do the male birth? We can do the subtraction, but I like you to use the formula. Just practice and make sure that the formula of subtraction and the formula that we learn from the class that make the same result. So we take total birth and times 1.05 divided by 1 plus 1.05. Is that correct? What if we do subtraction? Do we get the same number?
Yes.
Yes, the same.
Why do we need the same value in the next row?
We need only one. Just testing. Are you able to map the calculation that we make in the Excel map to the ideas that we learned from the diagrams? Are you okay? Yeah, good. No, I never learned this calculation from the class. I do it on my own. Yeah, it's difficult for me to do it step by step. All right, so what should we put here? So we are not done yet for the first year, for the first projection. What should we do? What is the formula? So we have to times survival ratio, right? Not everyone, not every children survive during these 5 years. So we take female birth only, right? This is female. And time survival ratio. So I think we good with the first period of projection. Let's move a little bit to see the graph. Not yet. We have to do something more. We have to sum, right? The last row is the sum. So we need to sum up the female population in 1998. Yes. And then let's take a look in this table and the graph. Yeah, just to make your life easier, I already make the graph for you. All right. Everyone is okay? Are you okay too?
Yes, Ajahn.
Good. Limon, are you okay? I think Abdul is okay because I can see.
Yes, Ajahn, I'm almost here.
Good. Yeah, congratulations. You now can project the first population on your own. Is there any question before we move to the second projection? The second period of projection. Okay, we move to the second projection. We finished projection for female population in 1998. Now we are moving to do the projection for female population in the next 5 years, which is in 2003. Okay, we do the easier one first in the in the yellow table. Can you do it on your own? If you cannot remember, so please follow. I don't remember as well. I go back and check the formula usually. Okay. So we take the number population, right? In the previous age group, which is this one. And time survival ratio, right? This one, right? Am I? Yep. We are going to estimate the number of population at age 9 to 5 in 2003. So we consider the population in age 0 to 4 in the previous 5 years or in 1998 and time the survival ratio. Now we are making the assumption. The survival ratio will not change over time during the projection period that we are going to make. Okay, we are going to make up to what year? 2023, and we will use the same survival ratio here. But you don't have to use the same survival ratio if you have better assumption. So for the later year, for example, in 2023, people can live longer. That means survival ratio is better. You can find the better one, okay? But here we just practice and we use the same survival ratio for the whole period of population projection period, okay? Now we come back to the year 2003 for the age group of 5 up to 80. So we just copy the data, copy the formula. Okay. And we do the same thing for the last age group. We take the population from age 80 and 85. Oh, and time survival ratio. Again, we use the same survival ratio here, right?
we can fix the cell for survival ratio.
Yeah,
Based
I thought they might be confused. I will fix later. Just finish and then we come back. And then we find which cell that we have to fix later. Thank you, Tim. All right, we finish this one. Then we calculate number of birth. Do you remember? We term 5-year intervals and then we times a specific fertility rate. And then we times the average number of female. Oops. You okay? Receive the same number?
Yeah.
Okay, now we sum up here. So we sum the total birth and we calculate female birth. We take total number and we times the sex ratio for female. And I like to do the subtraction because we test it is the result is the same. So I make it easier by using the subtraction. And don't forget to sum the total of oh, sorry, we're not done yet. Okay. Okay. Next, we will find the surviving female birth by having female birth times survival ratio. Here, right? And don't forget to sum total population in 2003. And let's check the graph. Yeah, it's going up, something changed. Okay. Now we done the second period of population projection. We will do the same thing for the rest of the projection period. So we know that Excel can copy the formula. Now we try to find which cell that we are going to fix to make our life easier. Just copy the formula. So let's see. This one, do we have to fix this? We have to fix, what we have to fix is the cell that we don't change, which is survival ratio. It's in column E. So I fix the cell. I fix the column, but not cell, right? Or you can fix cell anyway. But in this case, fix the column, that's enough. And for the next row, Again, we fix the cell. Now we fix only column again. We fix column E. We don't fix row because we are going to copy this formula for the rest, for the rest of this column. So just in case that earlier, as Kim mentioned, so you don't have to do it later. You can do right away that you are going to do the calculation, right? And the losses group, what do we have to fix again? E. You can fix the cell or you can fix the column because we don't change for the last age group. This time we don't have to this one. Okay, I think that's enough. So what do we have to do is just copy and paste. We copy these two columns. Okay. Column I and J. After you fix the cell now, otherwise you will get some errors. So I copy and paste formula. Something wrong. Oh, I have to fix the fertility as well. Yeah. Sorry. We have to fix column F. Okay. Is that correct, Kim? Partner. Sorry, you have problem.
Yeah, because I couldn't reach the point from the I can put it down. I have found the things. Here is the result. But where are the things? Those functions. Please.
Because we have to fix all.
have any problem to fix the cell, you know where to fix, right? If we use the same information, the same cell, and we don't change, we just fix that cell.
Ajahn, please explain about the fixed cell again. I'm not sure about I'm right or wrong.
Yeah. I think we should do one more here and then we fix the cell at that time. Okay, so let's finish this one and then we learn how to fix the cell. We are going to do another year, do another population projection. And then we learn how different between the previous one and this one. So I should go back. No, this one. So I remove the result. So I remove the result in 2003 and then we work again together and then we learn how to fix the cell.
Ajahn, can you please tell me how to fix the previous one? I just missed. My connection was lost for a while. Sorry.
The previous one.
Yeah, I got the calculation. Yes, I got the calculation, but I missed.
Which part?
Fixing the sales. I got the calculation for 2003. Then we need to fix the sale, but which sales we need to fix?
Okay. Okay, so if you did not fix the sale in 2003, that's okay. We leave it there. We will learn to fix the sale in the next projection again. We will do one more time.
Okay, Ajahn.
Okay, okay. Okay, again, I will do it again before we go have lunch. We do one more projection. Did every one of you finish 2003? We are now working on 2008. Can I?
Yes, Ajahn, we finished 2003.
Now in 2008, we do the same thing, but we are going to learn to fix the cell. Okay, we start from number of population of female at age 5. We do the same thing. We take the number of population in previous age group in age 0 to 4, and then we times survival ratio. Right, survival ratio is this one, right? And you see from the previous year, we use the same survival ratio. That's why I fixed the cell of survival ratio, right?
Yeah.
And we would like to copy this into the rest row. So I fix only the column. I fix column E of survival ratio. But I don't fix the row because we are going to move down to the rest of the row. Okay, then I enter. And then now I can copy the formula.
You can type a sign in front of E, and that will fix the only column.
You can press function 4, function F4 for 3 times, I think, and it will change. Or you can just type $sign.
Ajahn, which one to fix? The cell E actually?
E, we fix the cell that we are going to use the same information. And this cell we will never change for our population projection.
Ajahn, how to fix the cell E?
F4, you press
Function
F,
F4.
or you can type $signs. We need only one $signs in front of E.
Ajahn, E. Oh, okay, in cell in the newer cell, yeah, in 2008. Okay.
Yeah, we are working on 2008.
Okay, 2008. Sorry. Yes. Ajahn. Okay. Yeah. Okay, I got it. Okay, I was trying to fixing the cell E actually.
E.
Yeah.
Let's say in front of E. Because
Yeah, Ajahn.
we use the same survival ratio. Okay.
Yeah, we need to do it for the each cell, or just fixing one will be okay.
Sorry. We fix only column.
All columns, okay.
We don't fix the row because we are moving down to the rest of the row, right? We use the same formula.
Okay.
After you finish this, you copy the formula. So we finish for the first part. For the last row, for the last age group, we take number of population at age 80 and age 85. We don't have to fit the number of population because we are moving. We change this information and we times survival ratio. Survival ratio, we use the same, so we can fix the formula. You can fix both column and row as well because we don't change the row. We use only for we use this cell for only this row. Or you can fix only column. That's the same because we don't move the row. Okay. Now we calculate number of birth. 5 term is specific fertility rate. Again, we use the same as specific fertility rate, right? It is column F. Oops. It is column F, but we move the row. So we fix only column F. Okay. Not done yet. And we times number of female at the same age group. And we make the average. Is that correct? Right. So for fertility, we fix. Let's check the formula. We fix column F only. Okay. Next, we calculate total of birth. And female birth. Okay. So now we finish the calculation by fix the cell. Now we can copy the cell by copy the formula. Not done yet. Here, not done yet. So we take the number of female births and times survival ratio. Here, and then we have to fix the survival ratio cell or column. Okay. And we have to sum the total population as well. Okay, so now I copy the whole formula for these two columns and then paste the formula. Yes. Again, if you fix the cell correct and then you do the calculation correctly, so you can paste the formula again and again until the end of your population projection period. Right, and then let's check the graph. Yes. Now we finish the projection for female population. We use the base population from year 1993 and we project every 5 years to 1998, 2003, 2008, 2013, and 2018. So this is what we have. I take the total population to do the graph for you. We finish female. Okay. I think we should stop here. Is there any question before we take the lunch break and then we come back at 1?
Ajahn, while fixing the sale, my data has been changed.
Huh?
While calculating the
Why
birth.
right?
Sorry, Ajahn.
Why fixing the cell and the data has changed?
Yes.
Which data changed? Suppose
The total birth.
because we fit only some cell.
Yes.
To make the calculation, to make the formula correct for the rest of projection period. Do you get the right number? Do you get the same number as mine?
No, I am in the half of it, Ajahn.
Yeah. Where did you start to get the different number?
Yes. Okay, is the
You
yes, maybe I made some mistake.
share the screen. I think we should share the screen.
Okay, Ajahn, I'm sharing.
Okay, people, please help. Okay.
Because this number has been changed while fixing this.
Can you move your mouse away because I don't see the number?
Yes.
Can you double click?
Yes.
But I facing the whole column. Remote F9 just faces only me before the F.
Yeah.
Please
Yeah.
delete.
Yeah, very wise. Fix F
This one?
only, yes.
And now to drag it. Yeah. Now it's okay, Ajahn?
I think you get the different number, right? This is 2003 to 2008. Yeah, different number. Let's go check. Let me check. It's difficult to see.
Which column, Ajahn? This is the K. This is column K.
You are using the round same number. For the first one, is H9 L9. It's no H.
H,
J9. It should be
J.
J9.
K9. Okay.
JJ. Oh, no.
Sorry.
Double click to see the formula.
Yes.
Oh, yeah, I don't see that.
Yeah, the round one. And the first to the name also female. H, no, not H9. It should be J9.
Yeah. Revise H9 to J9.
Yeah, yes.
Lemon, because you wrong in column L and
G9.
J.
This one.
J.
Just click just at J. J9.
Click J9. Yeah.
J9, yes.
Okay.
Okay.
J9. Enter.
because
copy
the L column, you are wrong in the L column and the, yes, you plus in here L9 and yes, you not this only column. Yeah.
yes, cute. The whole.
Not the last one. The last one you have to do the calculation.
Yes.
No, I think it's correct. 5443 just.
Divided by.
Okay.
Oh, I need to calculate it first.
You can copy and paste. The formula will directly paste to the cell.
From here, this one.
Please delete the first one. Yeah. And then just copy the previous one.
This one.
Yes. Copy.
Oh.
No, you are applying the equation formula. Yeah, just delete the whole set. And
Yes,
remove the equation.
Don't write equation.
sorry.
Yes.
Okay.
Copy.
No, copy. Yeah.
Okay.
Yes.
Yeah.
Okay. And so.
I
the
cannot
same.
copy the same way.
Okay. Yeah, now I think it's okay.
Yes. So you can also face the ESID, the survival ratio. Yes.
Oh, not old.
Yeah. And also the last one,
This one?
the previous one, yes. You can also face,
Yeah, it speaks.
yes, you can also face the survival rate, yes. Only as play, yeah.
Yes.
You can just copy the whole thing and paste it in the next year.
This one?
You can copy study from the bar rate, 16227. You can copy, yeah, it's okay.
And also for here. Okay. Okay. So this
But
is,
also, yes. Tell the last,
We all
also the same.
K and L.
yeah, now it's okay.
Space
Yes, and copy the
27.
not but to the boss, bus.
Okay. Yes. Now is the same one, Ajay? I think.
What do you think? I think it's correct now.
Same answer.
Okay, thank you, people, for helping.
Thank you.
Thank you. I think I should stop here. And just in
Yes,
case
Ajay.
that you have a question that might, how to say, that you may have before the lunch break. So please let me know. If
Okay,
no,
thank you, Ajay.
yeah, you're welcome. If no questions, so we take a lunch break of 1 hour. We come back at 1:15. Is that okay? 1:15, and then we continue to do the rest for male population protection. Okay. Thank you. Thank you. We good.
Thank you ค่ะ
Thank you. Thank you.ค่ะ. We come back at 1:15.
Thank you, Ajahn. See you at 1:15.
Good lunch.
Thank you.
Yeah. Where did you go for lunch? Where did you go for lunch? Where? On the fourth floor. So you prepare your own food? Where did you go for lunch? The first floor. This building have food. That's omelet.
Yes, recording in progress.
Oh, I see. So everyone have an omelet. Yeah. It's a little bit difficult this time, but I think we in the opposite building, they also have some canteen. There is a canteen right there, right? I see. During the lunchtime, especially, yeah. Now so they prepare food from home, so it's easier. Yeah. What about people online? Did you have good food? People here have
Yes,
yes there. Where is your hometown, Abdul?
yes, my hometown is normally not my hometown at the Bangkok, but now I have the something in Korat, Nakornratchasima. So
So you have to go there, yeah. I see. So we will have to work for male population projection. Would you like to do it on your own? It's the same concept, right? Except number of birth, which you know where to get the number of male births. We already did it, right? Would you like to try on your own, or would you like to do it together?
I would like to do together with
Yeah,
you.
not a problem. Yeah.
Me too.
Thank you. Oh, that's thunder. We can feel the earthquake, right? Did you feel that thunder? But not earthquake. It's just my joke. Sorry. All right.
Ajahn, we can see your screen.
Yeah, I am about to share. So again, we have number population of male population and also the person year lived by the male population by age group. So what do we have to do? We have to prepare some information. We need to prepare TX. So we do from the bottom. For the very bottom one, we just type equal and click that cell. And for the next one, we make a simple formula. And then we copy the formula. Okay. I realized that people who are online, you have to minimize the resource on your own computer because of the internet connection. But you can send any emoji that to tell me that you finished the calculation so I can continue. Thank you.
I did.
That's very helpful. At least I have your response to make sure that you're still with me. All right. I think Limon, you are working, right?
Yes, Sajan, I am with you.
Are you done?
Yes, yes.
Okay, so we continue. Next, we need to prepare the survival ratio. So we do for the common population first, we take person year lived by that age, right? And divide it by the previous age. Is that correct? Yeah. And then we copy the formula. Now we do for the last age group. We take T, no, T85 divided by T80, right? For the first age group, 0 to 4, we take person year, right? Divided by 5 times radix. Is that correct? Yeah.
Can you share the last formula again?
This one.
Yeah, the last one. Thank you, Ajay.
You're welcome. So I get everyone finished. We don't have to do the fertility here. And so we move to the first year of protection period, which is 1998. We do for the common population first, start from age 5. So we take the number of population who are in the previous age group, which is 0 to 4, and times survival ratio here, right? Right. Yeah. If you know how to, so here we don't fix the formula, we will fix the formula in the next projected period, because the patterns of the this column is not the same. So we finish the first one. I mean, we have to finish the second one with fixing the cell, and then we can do the copy. Oh, sorry. Okay. For the last age group, we take number of population at age 80 and age 85 plus, and times survival ratio, right? Here. How can we get number of male birth? Yeah, just copy, right? Yeah. You just copy from the one that we already
Previous one.
did it. Yes, here, male. Yes, that's it. Right, Shimei? This looks strange. Why get different number? Not this one, no? Oh, yes, you're right. Number of female in time survival ratio, right? Yeah. Okay, if you're done for the first period, so we move to the second. We do the same thing. We are going to protect male population in 2003. So the best population is in 1998. Time survival ratio. Now I think we can fix the cell. Oops. I fix only column because we have to move to the rest of the row. I fix E, column E, yeah. Yeah, you're right. Thank you for reminding. Yeah, you're right. Yeah. Thank you. So I think you learn a lot, huh? Mm. Hey, can you finish 2003? Yeah, don't forget to fix the cell of survival ratio. But you don't have to fix the birth, number of birth, right? Because it's moving, right? Okay.
Arjun, can you share the second formula, the second age group? Because I have the different number in the second age group.
The second ratio,
Yeah, the second one, the 307, this one.
this one.
Yes. Yes, I don't know why I have the age 36. Oh, okay. Yes, now it's okay. Yes, thank you, Ajahn.
Yeah. Please don't forget to fix the cell.
Yes, I fixed them. Yes, already.
Yeah. The below one, the very bottom. Fix E. And the first one also fix E. Now I think you can, oh, I forgot to sum up. some male population. Okay, cool. You see, I some male population and I also did the formula to some male and female for the total population for you down here. Now you can copy the formula from 2003, copy and paste the formula. Can I finish every year? I finish up to 2023 and take a look on the graph. So you see, you fill in the information automatically. Yeah, this is the population by sex of each year or projection period, in the projection period. I take this information and then I do the graph for you to compare between male and female population size. You see, this is the size of population. How is the trend? What if I ask you to interpret the result of population projection? How can you interpret this graph? I need a volunteer. And the volunteer can be more than one. My question is, after you finish the population projection, and then I help you to make the graph, pretend that you did it yourself, you got this graph, how can you interpret this graph? How can you explain the graph? How many graphs that you have? Two.
Male and female has been increased. Maybe we can calculate the ratio that how much has been increased in those years from 1993 to 2023. In this 20 years, 30 years, the population has been increased for both the male and female has been increased. And we can see the number here from around 44 million. The female number has been increased up to 45 point something, above 45 million. And in case of male, the projection has increased from 43 million to around near about 44 million. But it also shows that the growth rate in case of male is higher than the female, because from the in the beginning the gap between the two projection line was higher, but in the ending the gap is decreasing. So the projection the increasing rate, the growth rate in case of male is higher than the female. Maybe my sense.
Do you agree, everyone? So you mentioned that the growth rate of male, right? Male female is higher. Limon.
Yes, Ajahn.
Yeah, you mentioned which one is higher than another one. So male or female is have higher rate of growth, right?
Yeah, the growth rate, yes, in case of male, and it also implies the total population as well.
How do you know about the growth rate?
Oh, no, I don't know the growth rate, but to me, because the graph is increasing, that means the population size has been increasing. during this period of 30 years. So if we see the two line, this is one for male, the blue one, and the orange one is for blue one is for female and the orange is for male. So the distance between the two linear line in the initial phase was higher than in the final phase. So that means the male was the below line shows the male has been increased high much more than the female. Otherwise, if the ratio remains same, the growth rate remains same, the gap between the two linear lines should be the same in the first and the last phase. But here, the first phase shows a higher gap rather than the last one. So my assumption that could be the higher growth rate in case of male, so that the gap has been decreased.
Okay. So what about everyone else? Do you agree or disagree? Or do you have any additional information that you like to interpret?
Yeah, in the population projection, the such ratio is changed in the 2000 study from 2003 to the 2023. And the previous 1993, the such ratio is above the 97.6, but the beyond that is around 98.93. So I think the growth, the range between the female and male is not much difference, and their growth rate is like the similarity. Then
Yeah. So you do the calculation for sex ratio, right? Yeah. Thank you. That's very nice. Is there anyone like to try? We do have two graphs, and we have this table. How can you make use of this information after you finish it?
We can calculate the H6 ratio, whether it was similar in 1993 or between 2023. Because the male and female are here, so we can calculate the H6 ratio.
Yeah.
And also we can show the how much the population has been increased, the percent population growth as well.
Population growth.
Yes.
What else you can do?
We can get the growth rate of male and female in each year.
Can you say that again?
We can get the growth rate of female and male in each year, right? I think.
Yeah. So we can do the growth rate. So I give you 10 minutes to think about how to make use of the information that you just have done. You spend the whole morning and almost half an hour in the afternoon to do this information, to do the calculation. I like you to make use of this information. I would ask you to spend 10 minutes thinking how to make use of this. You can do any calculation that you can think of. Do you understand my this? Yeah. Sure.
Could you please show me the calculations of the number of bed because I did not get the same result with the money because I cannot save my calculation because my laptop hour is running out, so I cannot get the same result with the morning section. That's why please could you please show me the how to calculate total number of please.
Okay, so but now can you show your computer so we can help you to fix?
Yes, okay, Ajahn, sure.
Okay, stop here. So make sure that you get the same information and then you spend time to think how to make use of the data. Please help too first. Okay. Oh, I see. E5 and H.
Am I correct or wrong, Ajahn?
I think you correct. Let's enter and see the result.
No, the number here, the F9, B9.
B9.
Yes, now it's okay. You can put enter. Yeah, it's okay.
Yeah, let's enter.
Yes.
Oh, you don't get the same.
Yeah, copy the previous one. Copy the previous one to the. You don't need to do all that. You can copy the last one. You can copy the.
Yes, I just copy from the first one.
I think the problem starts with the population that you protected in 19 column H. The population is
Number is
Can
same.
you
Number is same. It will be 15035. Can you please check the formula again?
This one? This one?
Yes.
The formula is correct or not?
the formula is correct?
Yeah.
And wrong is the reason that you don't get is the number population column H. So let's go to formula in the cell H7. Go up. The first one. Double click on H7.
Yeah.
Sorry, Ajahn.
To the first one.
So it will be B8. So it will be B8. B8. The previous one.
You are the first one. The first column in H6. Sorry, H column in the first cell. 248155. Please click. 2481, yes.
Yeah.
And please.
Double click.
Yeah, the long formula. B should be the first one.
I got it.
B6.
B6.
B6. Yes. Yeah. Now you can copy. Yes. Now you have the same.
Yes. Thank you very much.
And
And calculate the first one.
And yes, this one equal to
G26.
this one.
Yes. As a E.
cancel.
Yeah, E6.
And 2. This
Yes,
one.
this one.
Yep.
Yes.
It's so. Is to this one. Yes. I got the same result. Thank you very much, everyone.
Yeah. So you do the rest. Huh?
Yes, sure, Ajahn. Yes, thank you.
Please let me know if you don't get the formula right. Okay. Now let's get back to the result. What are the results that you received? So you receive not only the graph, you receive the information here in the table, total of population by sex, male and female in each year. And also you see the population in each year and by age and sex as well. Right? So let's think about this information and think about the resource, the material that you learned from the very beginning of your class. How can you make use of this data? How can you make any demographic indicators? If you don't remember the formula to do the calculation, it's fine. So you just let me know, okay, you just tell me what kind of information, what kind of demographic indicators that you can do the calculation, but you don't have to do it right now. You can think and let me know. Or if you can do it, you can recall the formula, you can do it on your own. That's a very good one too. So please try to think. So I give you 5 minutes to think, okay? Previously I give you 10, so it's past. 5 minutes past. So I give you 5 minutes more. Mhm. Something. There's something. Do you think we make a mistake? Yeah, I think you do make a mistake. Oh. What's wrong? Oh. Yeah, I did wrong. Oops. Let's just stop sharing. have to check your own data. I think something wrong with my own, but I'm not sure whether on your computer it's okay or not. Can you check the graph? I think something wrong with the graph.
Chan Jongjit,
Yeah,
I saw your Excel file. Maybe
yeah,
you?
just move, the cell move. That's why I asked student whether they know or not.
I think you just check again. It 37 is will equal B 36 multiple by E 37. It's okay.
This one.
Yeah.
Yeah, you see the graph. If you check it previously, you probably see the graph, the information taken from the year, not the total population. I think something wrong once when I revise the Excel. So you have to do the calculation of total population here. And then you have to create, you have to move the source of the data to be total population, not the year. You know what I mean? Yeah, and I have to change this one. Is that correct? I think, yeah. So the total population, once I check the total population, it's supposed to be around 8 million, 8 point something million. Previously, I think I did wrong or I pressed the button wrongly. So the population went up like 10 million something. So now I think I fix it. So make sure that the population, the total population in your Excel sheet supposed to be around 8 million, 8.9 million. Yeah. Right. Did you receive the same results?
Yes.
Okay, good. Yeah. Sorry, I'm wrong. Okay. Now, from this information, what can you do? What can you make use of the data? I just do something. I just add up the total population by age and by age. I combine both male and female. Yeah. I know what do you do. Is there anyone like to share? What did you do on your own computer? How can you make use of your data? I like to stop my first and then I like to see how students, how people make use of the data. So we can learn from each other. We can brainstorm. Is there anyone ready to be the first volunteer? You can do wrong in the class, no worry. So we always forgive you, okay? Yeah, please. Yeah, you can share your screen.
I just would like to share the one information that I just found. It's not the interpretation looking at the population projection. It's just the limitation, the delimitation regarding the population projection. So in it has been noted that even we are using the constant fertility rate to project the population for the next 5 years. It is sufficient to project the population, but according to even the fertility rate is the remain unchanged. As a result, the progression will be higher years by years based on the population projection. This is the well limitation by using the constant fertility rate for the population projection. That is why we are now using the constant fertility rate, and our reserve population projection gradually increase year by year. So this is because of the constant fertility rate.
Yeah.
That's all. Thank
Yeah,
you.
yeah. Thank you. Thank you for sharing. This is very good observe. So you observe that the number of births increase over the years, right? Due to the constant fertility. Why? Why is that? So we keep the fertility constant, but why we get the increasing number of birth?
Because we are calculating the zero and the first age group zero by using the constant fertility rate. So and also the next 5 years we also using the constant fertility rate by using this similar age group. It means that the population using from the previous one progress years by year. So yeah.
Yeah.
My understanding is
Yeah.
Because Ajahn, the total number has been increased in 5 years.
Yes.
So with the similar ratio, we have the increasing number of population.
So my question is why? Why we have increasing total number of birth? Due to the constant fertility rates.
The constant fertility rate is constant, but after 5 years, the population has been increased. The reproductive age group, the reproductive age population has been increased. So the birth has been increased with the same ratio.
Exactly. Yes, because of the number of reproductive female, number of reproductive population increase. Even we have the fixed constant fertility rate. But once we consider the formula, so we times number of female in reproductive age with the fertility rate. So we get the total number of birth. Yeah, that's why we receive the increasing total birth. Yeah, very nice. Yeah, I like the discussion like this very much. Yeah, please. Is there anyone like to share the screen? Even you do some calculation demographic indicators. The simple one that's good enough so we can learn from each others. I think I have to move around and see people working because you don't share your own screen. So I have to move to see what are you doing. No worry. Please open your Excel file. What do you learn? Yeah. What do you have? Yeah, interesting. Yeah. Would you like to share anything? You miss? Which one you miss? Oh, I see. Kunjia, would you like to share anything?
some information from another country.
Oh, okay. Yeah. Yeah. So let's practice on our own data. Oh, people who are online, please share your screen if you do some calculation from the data that you have.
Yes, Ajahn, give me a second. I'm sharing mine.
Okay, thank you. So when I move around, so people just turn out to Excel file. Yeah. So we make the class friendly and we learn from each other, no? So no worry about the mistake. We always make the mistake and we learn from that too. I listened to the podcast last night, and it's about the education, teaching in the class or learning in the class. And one thing that I learned, they said that if you ask question, the question make you full about 5 minutes. But if you don't ask question, it make you full forever. So don't worry about asking the question. Before you leave the room, you're supposed to ask at least a question to me. I think Tenki asked me, Tamina already asked me. Yeah, for the rest, please ask a question before you leave the room today.
I already asked many questions.
Yeah, you
in
did.
one session.
Yeah. Limon, you are about to share the screen, right?
Yes, Ajarn, but I may have some issues. Okay, let me share. I was trying to calculate the CVR, but I was trying to calculate the CVR. I don't know whether it's okay or not.
Okay, I see you do. Oh, what are you trying to tell me? Please go ahead.
Okay, I calculate the total number, and you already showed it. The total number in the from 1993 to 2023 in age groups, and I also trying to calculate the crude birth rate. Crude birth rate because we have the total birth in those years, and then we have the total population here. So I just divided this to calculate the crude birth rate. But in 1993, I don't know how to calculate the CVR in 1993 because we don't know the total birth in 1993 because we calculated it for 1998.
So in 1993, you have population from 0 to 4, right?
Yes, 0 to 4, yes. 0 to 4, yes.
Yeah, from this formula, you cannot find the total of birth from that year.
Yes, but we can calculate the crude birth rate for the next
Yeah.
pages because we have it in 2008. 2008, this is the 2008 divided by the number 2008.
So what if you really need to find the number of birth in 1993? How would you do it?
The total birth?
Yes, for 1993, if you really need to do it.
Okay, so we can divide the number. We can the total birth from 1998. We can just minus the total number in 1993. So that will be the total growth, the total birth in those 5 years.
You mean the different number of population?
Yes, the different number of population. This is the total growth in these 5 years.
It's the growth, right? But it's not, it doesn't mean to be the total birth.
Okay.
So I throw this question to people in the class, all of you, think about. Now we have total birth from the year that we do the projection from 1998, but we don't have total birth for 1993. If we really need it, how can we find the information? You can go to the internet and find it, right? But if you like do for some countries that you cannot find from the internet, how can you estimate the number of total birth in 1993? Wow. Yeah, I like this question. Do you remember our last class? Exactly, yes. We use a trend line to do the estimation backward, right? Yes, just to estimate, if you map the total number of birth in the line, and then you find the equation, right? So you can replace the year, and then you can find the number of birth backward, right? Do you remember? Yeah. Yeah. So now you have the crude birth rate, right?
Yes, I have the crude birth rate.
Right. Oh, how do you calculate it? What is the
crude birth rate is the total number of birth in that year divided by the total number of population into 1,000.
Yeah, and the total of birth that we have in the cell is for 5 years, right? So if you need to use it, so you have to
5 years. So we have to divide it by 5.
yeah, so we have to divide it by 5.
Okay. Okay.
So actually we don't times 5. You remember the formula 5 times is specific fertility rate and the average number of women between time t and time t plus 5, right? So if we need 1 year, so we don't time 5, right? Yeah, and that's the number that we get, the number of birth per year, right? And divided by total population of that year, right? Yeah, roughly.
Yes.
Roughly, yeah. Thank you. Thank you for sharing, Raymond. Thank you.
Thank you. Ajahn.
Yeah, is there any other ideas? Yes. You like to share the screen? Oh, no, no. Yeah.
We can calculate the dependency ratio, future dependency ratio, working age population, and population pyramid by using the 5 years age group of the population projection.
Yeah, so you can do population pyramid. You can
Dependency ratio, time dependency ratio,
Yeah.
also like the working age population
Mm.
and the overall dependency ratio.
Yeah, right. So the dependency ratio, how to do the calculation? So we take
Take 0 to 40 plus this is 65 average plus multiplying by the working age group. So 50 to the 50 to
Yes.
64. Yeah.
Yeah, that's good. That's so now you know how to make use of the data. Thank you. Yeah, thank you. What about other indicators? Do you think is it possible to tell when the countries become aging population?
Sorry, Ajahn, countries.
So is it possible to use the population projection to tell us whether the countries become aging population? So how can you tell from the population pyramid that, okay, these countries become aging population? So please forgive me. Now, I just all of the questions just come up to my mind, so that's why I ask and ask and ask again. So please don't take it personally. I like to think more and more. Yeah, please help me think. When I ask question, that's mean I ask everyone, not only just Tamina. Let's think. Mm-hmm. 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 Yeah. Yeah. Is there any indicators to tell that our countries become aging population?
I think we calculate aging index.
Aging index.
Yeah. Is the number of elders population in the area 65 and over per 100 younger than 14 years old. Aging index is about the age population.
Okay, elder population divided by children, right? So this is the aging index. Is there any other indicators to tell us this is aging population? So what is the cutoff? Huh? Yeah, what is the definition of aging population first? Do you hear me clearly, people online? You can answer.
Yeah.
Yes, Ajahn, we can
We
hear
have
you.
only female here, and all of you are male population. Yeah, please help our student. Yeah. What is the definition of aging population?
Increasing the median age for the because of declining the fertility.
65 years or above, the population group of 65 years of above.
Sorry, can you say that slowly? I cannot.
The population group above 60 or 65 years of age groups.
Yes, they are aging population. And how do we identify Thailand or Vietnam become aging population? How can we identify it?
You can see the total number of the population above 60, or maybe have the can see the proportion of increase for the previous 30 or 20 years.
Okay, what is the cutoff of total population of aging population? That can tell you.
I think median age can show us if median age is above 30, the population is quite old, and 30 is the cut point.
Yes, exactly. This is the definition, one of the definition. But let's get back to our data. Can you tell me what is the median age? Can you tell me? This is the real life of demographer. You have to understand.
Median age group is refers to the point that is divided the population into two groups. That is, one is the younger one, and the rest of the is the older one.
So that's the aging index, right?
Yes, the median age group.
The median age group, yeah. I asked, my question is, from this data, from the projection, can you tell me the median age group of in like what year? 2003. Can you tell me what is the median age in 2003?
In 2003, we can calculate it.
Can you tell me?
The median age.
Have to stay in the middle here. So people try to do the calculation, right? What is the population that make the population into two half? Okay, let's say it again. So you take total population and divide it by 2, right? And you get the number of population. Okay, let's you do the calculation. Okay, I will do it too. So still, my question is, what is the median age? Or can you find the median age from the population projection with 5-year interval?
Yes, we can find that. We have this formula.
Okay, let's do it. Okay, let she do it. I let her finish and then we see. Oh, it's fun, no? Sue is helping us to do the calculation for median age. Oh, yes, I can send to the chat box so everyone can have it. Yeah, thank you. How to save. Yeah, everyone can download this data and you can use my calculation. For those of you who have no idea how to calculate the median age, you can move on and think about other indicators that you can identify a country's becomes aging population What else you can do? 46? Yeah. And my question is, how do you, can you show on the screen? Can you share? It's okay. I don't have any marks or score to give you. We just learn. Can you use a microphone so people online can hear you?
So at first, we have two population size, male and female, and this is the combined data for male and female, and then this is the cumulative for the population for each interval. So in this case, we will get the total population. So to find the median age, the total population divided by the two. So we got the middle population groups. So in the middle population group, we have to find the lower and the upper age range. So 445 is this is the first lower age range, and this is the upper age group. So these are the two population. So in this case, we are consider like, and we need to the paper suggests to use the lowest age group, 30 age, and this is the formula. So 35 plus, and the F20 means that and the result from the divided population minus or subtract from the E9, the first one multiplying by the and the upper age range, subtract from the lower age range. So we got this formula, but in the paper it suggests to have the plus for one and to be the and to validate the median age population. So I just subtract one. So the result is the 36 for the median age.
Can you show the formula again, please? Formula is, yeah.
Yes.
So you take F the different, and then you divide it by. Okay. Do you approve?
But I think there's something wrong in this because if they find the middle in arrow 40 and 45, and the alien index is in the middle group, not in 6 form. 46 is about it's not 36 is about under 40. Not in lower.
I see. So the cumulative, the number of population here, sorry. And how to say, 44 million, right? Not 44, 44 something. It's over the age between 45 to 39. So it's over, right? So you see. Yeah, it's supposed to be higher than 49, right? Right. So to me, I have no formula at all, but that's why I am interested in your formula, but I'm not sure whether it's right or not, wrong or not. But now you can see it's difficult to identify the median age by using the population for 5-year interval. Right, it's difficult to identify the median age. Yeah, but at least you know that it's higher than 39 because 44 million something, it's more than it's in the age group of 40 to 44. It's somewhere between 40 to 44, right? Yeah, that's what we know, but we don't know exactly. Probably there is a formula to do the calculation for median age, but by now we have difficulty to identify the median age. Okay, so we move to the next indicators. What if we would like to tell Sweden become aging population? How can we know that? Is there any other indicators that you can tell? Hello, gentlemen, please help ladies. Have you heard about proportion of aging population of older person? The proportion of older person. Yes. Yeah, it's increasing. Yeah. Yeah, so now every countries in ASEAN countries, you have increasing older population, every countries. But what is the cutoff that tell, I think Myanmar, who was from Myanmar, you, right? How can we know that Myanmar become aging population? I think Myanmar already become, right? Just recently. Yeah. Just recently become. What about proportion of older person? So you never heard about this before? Proportion of older persons.
On the number of population in age 61 to 85 divided by the number of population.
Yes, yes, this is the proportion of older person. So we take the number of older person divided by total population. And what is the cutoff? How can we know Thailand become aging population? Some countries use age 60, some countries use age 65. Yes. What is the cutoff? How many percent that you can tell Myanmar become aging population? Yeah. 10%. So if we use 10%, that means we use age 60. See? If we use age 60 as the cutoff of older person, the proportion of population from age 60 and over divided by total population, if the proportion or the percentage is 10% and over, that countries become aging population. What if you use age 65? So the proportion should be lower, right? So we use 7%. Okay. Okay, please take the note. This is very important. I don't have it on the slides. Yeah. So now this is the issue around the world. So you have to understand when a country is become aging population. You can use many indicators, but it's depend on your data that you have, whether you can identify the aging population or not. From this population projection, we learned that median age is a little bit difficult to identify, right? So we changed to use the proportion of older person instead, right? Yeah. And we need to know the cutoff. Now we know that 10% is the cutoff. 10% of older person at age 60, right? But some countries use age 65. You have to know what is the cutoff for each indicator. Mm. Yeah. Should we take a break? What time is it? Yeah, 2:30. Should we take a break and then come back? I don't know what to tell you more. So please prepare the questions just in case. Or if you like to practice more on the Excel file, please let me know. Actually, I have an assignment. It should take like 15 minutes. I would like to ask you, okay, let's give you this assignment, just 15 minutes to find the information. I would like to ask, what is the assumption that the UN used for population projection for your own countries? You probably find the common answers, but let's specific for your own countries, just in case that you like to take a look on your own data. Okay, please find the assumption that UN used for the role of population prospect in this current revision, which is 2022. It revises almost every year, but not every year. Yeah, but the most recent one is in this year to 2022. Yeah, let's find the assumption that they make for doing the population projection. Okay, let's spend 15 minutes after the break. So let's like discuss at 3 o'clock. We come back and discuss about the assumption at 3 o'clock for 15 minutes, and the rest you can ask me to do anything, to do the exercise or anything, or after the break you can ask the question as well before we work on the assumption. Okay, is that clear? Okay,นะคะ? Okay. Okay, we stop here. And then I will come back to the class at 2:55. But you have to do on the assignment to find the assumption, and we start discussion at 3 o'clock. Okay, let's go. Now it's 3 o'clock. So we will spend around 15 minutes to discuss about the assumption that you just have learned from UN population prospect. Right? Did you find anything interesting? Tamina, would you like to start?
Okay, Ajahn. Ajahn, I just do the thing that from World Population Prospect data into 2021 in Bangladesh. I got the proportion of old age population in 2021, that is 5.8%. So when we go for the population projection, so our assumption will be that based on this analysis that still Bangladesh is not facing the aging population right now. So it means from my understanding that it means the population working age population is comparatively higher in Bangladesh right now. So from next few years, probably the working age population will be higher, so which is called the demographic dividend. So after then, because the as the population will increase in certain growth number when we do the population projection. So in case of aging assumption about the aging population, we need to focus on right now. Our assumption will be based on the working age population, that how the working age population can be utilized in our country, and then we think about the old age population ratio, because this working age population will be older at a certain time after certain time. So we will think about the this aging this working age population, that when they will go for the when will be they older, what will be our policy. So we have to utilize our working age population right now.
Is there any assumption about fertility, mortality, or migration for the population projection?
For population projection, we just firstly we think about there is no migration, close migration. So the fertility, mortality will be in the constant rate or any rate. And but if we consider about the migration, then we have to consider about the fertility and mortality, because if there is any migration, there should be some rate of fertility, mortality in different rate.
Yeah, so usually there are many scenarios for population projection each countries. Do you find any like one scenario or more than one scenarios?
Sorry, Ajahn.
Oh, scenarios.
Scenario.
The possibility of population projection, for example, like in Thailand, we have 3 or 4 scenarios. For example, low fertility. The first one is for low fertility. The second one is medium fertilities. The next one is constant fertilities. I mean, the same rate as the present one. And the last one is high fertility, for example. Yeah. So we have like the result of population projection in 4 sets of results. This is we call scenarios. Yeah. In the UN prospect, I think we use medium scenario estimate, the medium estimate, right? For your assignment, did you download it? Which scenario that you use? Right? You use the medium one, right? Yeah, usually we use the medium one. So what did you learn from the assumption of UN? Yes.
Ajahn, I just use the estimate.
Yeah.
Just this one.
Can you compare estimate and
with median variant? Okay.
Yeah,
so okay. After
right, it's the same, right? So you compare. The
Okay.
same year.
Yes, no,
Yeah.
not the same year.
Yeah.
In the medium variant,
Take 2022, you compare the number
but I
of
can
population to
estimate there is no 2022, 2021.
yeah, so you compare 21.
Okay,
Can you compare?
21 with 22.
I mean, you have to compare in the same year. It's supposed to be the same number.
No, Ajahn, but the data is not. Okay, then I will check.
Yeah.
Sure.
Yeah. So once you download the data, you have to understand what kind of data you are using. Right? You have to understand what is the source that you can use, what is the method, what is the assumption. Hey, who next?
You have also used the Google Internet. Yeah, so I just read the methodology for the UN population prospect. So in before the 2022, there is a UN population prospect for the 2030, and in the 2022, they re-estimate the total fertility modality, including the modality status for the COVID-19 and details both to the estimate assumption for the future projection and re-estimate the population projection from the 2022 to the 2100. So in this case, they are using the median estimate and also the previous historical data of the fertility modality and also the migration data put together and re-estimate the population again. So including Myanmar, yes.
Yeah, this is very good. So you learned that they take fertility, mortality, migration, as well as the new mortality from COVID-19. So they have to consider the pre and post COVID situation, right? So they have to re-estimate. Usually, if I remember correctly, I used the data in 2017, 2019, and 2021. Now this year is 2022. They released the new version. So you see, they do it every year. They did it every 2 years, every 2 years. But this year, because of the COVID, so they have to re-estimate everything again. Yes. So we have to understand what they consider and the assumption that they made. So you can tell that the fertility scenarios, there are more than one scenarios for your own countries, right? And you have to pick the right one that you trust, that you believe it's a match, the best match for your own countries, right? Is there anyone like to share? No,
As such, the data source for Myanmar and Nepal, they use 1973 census, 1983 census, and 2014 census, and also they use Myanmar 1991 population change and fertility survey, and 1994 fertility and reproductive health survey. And they also use 1999 National Mortality Survey and 2000 Multiple Indicator Cluster Survey and 2001 Fertility and Reproductive Health Survey, 2002 to 2003 overall and cost-specific and 5 mortality survey. They use many data sources and they consider fertility, child mortality, adult mortality, overall mortality, and migration data from these data sources. I think we don't have much data sources, but I found many sources.
Yeah, now you learn there are other sources other than census that you can make use to do the population projection. Yeah.
In my country, I find assumption about fertility is if they have three assumptions. First is low variant. This is the total fertility. Delay data. Delay around about 2 plus 1 2 to delay to one delay to one plus 1.85. Yes, and next assumption is they assumption the fertility is about 2.1. This is children birth woman is replacement level fertility. Yes, in my country have this. And about mortality, the assumption is the life expectancy of birth is increase. Yes. And about migration is zero. Next migration is zero.
Yeah, that's very nice. Now they make assumption for fertility. They pick a TFR for, I guess it's medium, right? It's medium variant. Yeah. They consider the TFR for fertility. Once you consider the TFR, but as we learned in the morning, so the formula contain no fertility. I mean, we use a specific race fertility, but you can calculate back to TFR. Is that possible, right? Can you calculate the Yes, can you do that for me? Can anyone help? For Sweden in the morning for the data. Yeah. 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 Right. So you pick the TFR that you can expect your countries to have that level. And then from that TFR, you get a specific fertility rate for that TFR, right? Yeah, and then you use it in your population protection. Yes, that's why we consider fertility, and they identify it by TFR, right? And they also mentioned the mortality by life expectancy. Yeah, yeah, and migration is it's a zero, like close to zero. So that means there is no substantial migration that affect to the population change within that projection period. Yes, this is the assumption. And we also learn from Tenki, right? That we not just only consider the common, the conventional mortality, but we also consider the situation of COVID-19 as well, right? Yeah, that's why they adjust the population projection for UN. Yeah. Try.
Yeah, also in Thailand, the source of that UN use for estimate the population projection is from the census in Thailand to calculate about the fertility and child mortality. So, but in another indicator like migration or net migration, they use estimate method to calculate the number of migration in this country.
Right, thank you. So we learn from many countries, but the basic thing is the component of population that they consider as the assumption as the input for population projection here. Is there anyone else who are online?
Yes, can I share in the Thailand report projection from 2010 to 2040? Hello, can you hear me?
Yes.
Okay. The assumption from fertility, yes, they have the three level of fertility in the high fertility, medium, and low fertility by using the TFR. Is at the TFR in the high fertility, TFR is the 1.62 in 2010, and they use the assumption of the moderate fertility at the 1.3 and lower fertility rate 1.2 in 2040. Yes. And they have assumption in the mortality. Yes, in 2010, they used the life expectancy at birth at 70.5 years. Yes, in male and female is the 77.8 in 2000. Sorry, in 77.8 in next 30 years. And, have the in migration also. Yes.
What about the assumption of migration?
The migration is they use the population the number of migration in 2010 that is report in 5 years equal 700,000 around 700,000 from 2013. Yes, and use the net migration.
Okay, so the map. So for Thailand's report, it's the what is it called? Population projection from Thailand have done by PSR. In this case, it consider the migration as well, but they use the estimate number as Abdul said. They use the 700,000, right? So the migrants that they use.
100,000.
Yeah. So they take this number from somewhere and then as the total migrants. I'm not sure whether they distribute these migrants into the age group or not, but what I remember.
Yes. In age group,
the
5-year interval.
Yeah, so they just add the migrants into each age group that they can distribute. But again, I'm not sure whether they use this population, especially for female population, for the best population to calculate number of births or not. Right.
Yes.
Yeah,
0 to 4.
no, yeah, we don't know. Just to add to the population projection by each age group, but we don't know whether they use this number as, let's say, or for the best population, for the best female population to calculate the birth or not. We don't know, right?
Yeah, I don't know.
Yeah, thank you, Abdul. So,
Okay,ครับ.
a lot, huh? Is there anyone else like to share? No, to anyone?
Turn. I'm just confused still. I'm still struggling to find the date actually.
Okay, just for PhD student, you will be always asked about the assumption of population projection. Please be aware of it. Okay, you have to do your own homework for this too, for your QE exam. Yeah. Is there any question or is there anyone like to share anything?
Ajahn, I have questions. In the morning section, you asked, you said to estimate the fertility and mortality. How can we estimate this fertility and mortality?
How can we estimate? Can anyone help me? Fertility and mortality.
about mortality and fertility we have in census or in population process. It have in this. You can download. And about NHAM mortality, we will calculate about light table. You calculate a specific death rate and calculate the light table, and then we calculate on and a specific death rate.
Okay. Let's think about the fertility class and mortality class. How can you do it? How can you get a specific fertility? Let's think about fertility class. This is not my class. All right. How can you get a specific fertility?
The number of birth in
How can you get fertility, a specific fertility? Where is the source of the data? I think Abdul is about to say something, right?
yeah. I use the number of birth in that year and divide by the number of population in each age group.
Yeah. So I'm sure that you can do the calculation, but where is the source of the data?
From census or
Think about fertility.
Census, vital register.
Census might be, but if you do the census every 10 years, right? So the fertility rate is not that updated. Is there any other source that you can find the fertility data?
Vital register.
big yearbooks, UN.
Survey. Yeah. So you can find from fertility survey. Almost every countries have fertility survey. Or you can find from VHS for some countries. Civil registration, right? Yeah, civil registration. So this is the source, and what input that you need to do the calculation, live births, right? And the media population or the population of each age group, female population, right? Now you know how to find the information for fertility, okay? Are you okay too? Now you know where to find the information.
Please ask again, Kapachan, because the signal is not okay.
So now we learn that where can we get the information for fertility, right?
Actually, I did not hear clearly on your voice.
Okay, again. So a student in the class mentioned that the source of fertility information you can get from census, you can get from fertility survey, you can get from the VHS survey, and from civil registration. And the information that you use to do the calculation is number of live birth by female population for that age group. Correct me if I'm wrong. I'm not teaching fertility. I'm not good at all. Is that correct? Right? Yeah. Okay, now we're good with fertility. What about mortality? Oh, can you use the microphone? Microphone, please, if you like to speak. This one, yeah.
ASDR is number of death divided by number of population of that same age group.
So So you get the mortality, a specific mortality.
Yes,
Yes.
a specific mortality rate or death rate, ASDR or ASMR, same.
Yeah, yeah.
And the sources are same from census, from the survey, from civil registration, from all this, we get the
Yeah. Pretty much the same source.
yeah, same
Mhm.
source.
Yeah, if you have your own country's life table, you can use it. But if you don't have that, how can you find the information for the person here that you use in the population projection? If you don't have life table for Madagascar, huh?
We don't have light table, but we have the depth. But the area we can calculate light table. Use it to calculate the light table.
Yeah,
Yes, and
yeah.
the light table, some data exists to.
Yeah, so in the case that you can find that kind of information, you can calculate your own life table,
Yes,
right?
yes.
But if you don't have that data, model life table. Actually, we use model life table because we believe that model life table is the patterns that we can trust to do the population projection. You know, the life table that we do, I usually don't use my own life table to do the population projection because, you know, if you do on your own, you know, you can find from somewhere else, you can find from UN, you can find from other website. So different source, different numbers, right? So different source, different number. And the question is which source that you have to use, that you should use. Usually to do the population projection, especially for Thailand, I think. No, I shouldn't say that because I didn't do it. Usually the demographer use model life table that they believe it fit to the situation of their own countries. For example, in Thailand, we use the West model. We consider the West model, and there are so like hundreds of thousands life model for the West model. So we need to consider. So how can I select only one model for my population projection? You already answered this. Life expectancy, we consider life expectancy that fit to our data, that fit to our situation of population situation, right? So life expectancy, and what else? I've been mentioned this morning, it's mortality patterns. And what is the mortality patterns? Infant mortality rate, under 5 mortality rate, and for each age group, right? So you have to consider each age group as well. Yeah.
My question is, in the UN population project, they also project the numbers of death in the future population. So can we use the similar equation like the population projection? So instead of population, the total numbers of male and female, the population will be the death number. And we are using the modality, or how can we estimate the numbers of death for the future population?
How can you estimate?
Yeah.
Different
Or the other country.
Actually, this is my question is the same as Amantengi. Uh, I want to know the future fertility and mortality because we have seen the future fertility and mortality and the graph of the world population prospect. That's why I want to know the fertility and mortality in the future. Same question with Amatengi.
I see. So what did we do in the class?
What did we do in the class for fertility and mortality in the future? We make an assumption. No, in the future, we just make an assumption.
Right. So if your assumption for fertility is supposed to be like constant within the first 10 years, so you use a constant fertility for that period. But after that 10 years, another 10 years, it's supposed to be like a little bit lower. So you make an assumption again, and you make the fertility to be lower. You can find any other patterns that you think it fit to your country's data. And in the next 10 years, if you think it should be lower and lower, again, you make an assumption. It's depend on your assumption.
So, I have one question.
Just scratch your head.
Yes.
Yeah.
So in the one thing for the fertility situation, we can assumptions by the many things like high fertility, low fertility, and very low fertility like that.
Yeah.
In the one of the projection. Right?
Yes, exactly. Yeah, we learned from UN and for Thailand's report. So they have medium, high, and low. So for medium, they use, I guess, I don't remember exactly. They use a certain level of fertility, and they use it for the whole period of protected period. Again, for low fertility, they use one certain level, lower certain level for the whole period. But from our lecture in the morning, you see at the notes, you don't have to use it for constant for the whole period, but it depends. But if you change the assumption at any time in your projection period, you need a reason to explain. And it's supposed to be a very good one too. Right. Yeah. We do the same thing for mortality. Yeah. But I think mortality, it's supposed to be getting better and better. Because of the life expectancy is increasing, right? So it's supposed to be better. But the fertility is getting lower, usually. But it's depend on the countries. Did I answer your question too? Did I answer your question? No, or not yet.
Actually, I don't get the point, Aja.
You didn't get
Because of the internet connection? Or because of me, because of my explanation? Please, anyone help me to explain. You don't get the question because of the connection or because of myself? Or because of my answer?
To know how to estimate this that rate. We have to do assumption, right? Maybe he want to know how to do assumption. Is that right?
That's a good question. How can we make the assumption? Yeah, this is a very good question. Really. So first of all, we consider the data that we have. If you have the data, very good data from census from the survey, you use it as an estimate, and then you use that as the input for your population projection. But in the future, no one knows in the future. How can you estimate it? That's why you need some expertise. That's why you need some expert to help you to do the projection, to foresee the situation in the future. We don't know. That's why we have so many scenarios. We have will, we have maybe, we have scenarios. See too. Yeah.
So it's like an expert job. So we are beginners.
Yeah. You know, to do the Thailand's population projection from IPSR only, we have like อาจารย์ประโมทอาจารย์ปัทมาอาจารย์มาลีอาจารย์สุริพรอาจารย์สุธิดา I think it's 5 people that I know from IPSR just to do population projection and from NESDB, National Economic Development Board or something. There are a team, a big team. And there are also expertise from other universities, from Chulalongkorn, from College of Population Studies. A few of them from that. You see almost 20 people. Just to do Thailand's population projection is not easy at all. Once Ajahn Pathama, Ajahn Pamon get the results and they propose to the board and see, they get the reflection. Oh, we have to revise that, we have to adjust that, is that possible? So we have to discuss a lot. To do just, we do I think we do every 10 years, but we also do have the revision as well. Yeah.
Even though I don't know the exact calculation as I have read for fertility, there is like trend or how much the speed of fertility declined. It is written that in the boat, they said the fertility decline is like 5% or 0.5%, or it's like that. They studied many countries' fertility declined. They calculate the exact percent decline of the fertility rate. So we can assume that how much percent the fertility will decline from that period. I think like that.
Yeah, so we need expertise, right? Yeah. I don't know. I myself, I don't do the population projection. I'm not in the team of population projection. I learned from the report and from UN as well. So, yeah.
Ajahn, sorry, but in normally demographer, they will take the population projection in how year, like in every 5 year or in every 10 year.
Usually, yeah, we can't expect that thunder. We have census every 10 years. After we get the census, we can do the population projection immediately after we receive the result from census, because we have the most updated data. So we can do the population projection. But after a while, for example, after 5 years, we also have the civil registration. They usually update every year. But once we learn that the Ministry of Interior released the new number of population projection from civil registration database, so Ajahn Pathama take that to revise the number of population projection. Okay, so if we believe that the most updated from civil registration make the difference
of the population protection that we have done in the past 5 years. So why not? So we should revise the population protection, right? So, but from UN, as I mentioned, they revise every 2 years, but this year, the previous one is the revision in 2021 and this year 2022, and they released the new one. So after they receive the new information, they take this for consideration and revise the population protection. Yeah.
This is not related with our current discussion, it's just my concern. So in Myanmar, we have 2019 in the census survey. So I would like to know that the inter-census survey is always conduct the inter-census surveys in every country, or this survey collect from the inter-census survey is how affect the whole census data.
So what is the survey again?
Yeah, so in Myanmar, we have official survey, and there's a two official survey, 2017 and the 2014. This is the country census survey. But in 2019, there is an inter-census survey. We collect. So in the beyond that, the most of the organization, including the UN agency, are using the 2019 inter-census survey as a census before move to the HUS census in the 2024. So my question is, if I learned that the inter-census survey is always contact between the middle of the one surveys to the previous survey, like the 5 years.
The post-enumeration.
Yes.
Like the post-enumeration survey between the census.
Yes. And so my question is, these we can also this inter-census survey 5 years duration between the first census survey before the future census survey. So how this census survey can village for the whole population.
Sorry, the last question. How the census?
Yeah, how and the data, the collect from the inter-census survey is how affects the whole population, whole census information. Yes.
I think I lost the last question. I understand the situation. You have
Census every 10 years, and then you have inter-census survey. And how can you make use of the inter-census survey to the census for the estimate, right? Is that your question?
Also in the UN population prospect, they use the HUS official census data to calculate the future population trend. So like Myanmar, we conduct the inter-census survey in 2019. So these data set collect from the 2019 is considered as the village or not? I mean, so can we use these data set as the whole population data set as a 2019? For example, in the 2020 census data set, we got the 44 million for the whole population. But in the 2019 inter-census survey, it's called like the 53 million or something like that. So these data, how village to choose?
So this is from an experience in Thailand National Statistics Office. They do the census every 10 years, and they do for the whole countries. But for the inter-census, it's called post-enumeration survey, I think. They don't do for the whole countries. Is that similar to your countries? Yeah. So
in 2019, they didn't do the whole country.
So they just like pick some area, I would say sampling some area to represent the whole countries, but do not do the census for everyone in the countries, right? So this is one of the limitation, right?
to make use of the intercensal survey, I think you can adjust a little bit to see the trend. But usually I never see they use the intercensal as the best period data. I think it used to adjust, for example, you use the best data, you use the best year data, and then you do the projection, and you see the trend, right? And you never know whether it's correct or not. But you have the intercensal or post-enumeration survey. You can compare whether the proportion of the older population or the working age group is in the same trend. I think it can be used for validating the data, but to my knowledge, I never see they put that data into the population projection. Yeah. Hopefully it helps. I don't have that much experience living on my own.
Using these data set by applying a lot of human resource and the money for the budget, just thinking out of the box.
Yeah, you remember, if you recall, the population projection, the data that we need to input is the life table, LX, from life table and the fertility. You can use the fertility from intercensal survey just to update the trend, right? You can use the specific fertility rate or the person year lived by age group. So you can use that for testing your calculation your calculation use the main source from census, but you can use the intercensal data just to check for the trend of fertility and mortality, I think. Yeah. Yeah, you can make use to create the fertility patterns and mortality patterns from that survey, I think.
So again, for United, raw population process estimation, they use different birth rate and death rate every year, every single year, right? They use different ways for projections, right? But not like we did it in the exercise, right? Because ways are different. No, usually we don't change it every year. We don't change fertility and mortality patterns every year because it's very difficult to define why you change it and why you pick that rate, why you pick that patterns. But we saw different fertility and mortality rates in the UN data when we find like crude birth rate or crude death rate or crude fertility rate. When we find these indicators, we find different rates in each year. So did they consider these rates to do projection, or did they just estimate these rates?
Do you mean the rate that you calculate from the result? I think I lost. Can anyone help me? You mean the input or the result? If the result you calculate it from the result, it just it's I don't know.